Welcome to my brand new tutorial over the JPizza programming language. This will be a fully comprehensive tutorial that will cover every aspect of the programming language and include a few projects in between to keep you entertained and also test your skills and really recap everything that we've learned. So the first thing you want to do is you're going to want to go to the link in the description for the GitHub repository. Then you're going to get the latest release. And there will be a newer release than this once I publish this. But you're just going to download whichever repository you want, tar or zip. I'm going to download this. Now you're going to want to extract it. And once it's done extracting, we're going to open it. So now that we're in here, we're going to go into JPizza Shadow. We're going to go to bin. And here we have these executable files. You're just going to want to add this to your path environment variable. And if you don't know how to do that, you can just open environment variables. And here's your path. And you can just click new and add your JPizza to it. It's a pretty simple installation, and then you should be able to run it from the command line with just the command JPizza. So here we have some JPizza code. We're not going to go into it, but we are going to learn how to run it. Now you can compile it by typing JPizza, then the file name, and then using the C flag for compile. This creates a JBox file, and you're not going to be able to get anything from this, not even the source code. So don't even worry about opening this. But then we can run this file with the run flag, R. And you see it does exactly what we want it to. However, if you don't want to compile the file, you can run just the source code directly with the run flag. And you can also refactor the source code with the RF flag. This will catch stuff that we'll go into eventually, but things like it'll tell you how to improve your code and yell and scream at you and a bunch of other stuff. And it's really useful if you want to write clean, concise code. And then there's other commands like help, which will tell you all the different commands. Yeah, one's like O. So if we use the O flag and then app.j, just app, it'll compile to app.jbox. If we do V, it'll give us the version. I guess it's not really working with right now. And if we do docs, it'll give us a link to the documentation. To start messing around with JPizza, we're going to mess around with what's called the shell or the REPL. Now, this is simply launched by just typing JPizza into the command line, assuming that you have it hooked up with the command line. This allows you to type in JPizza expressions quickly without having to hold it to a file and compile it. Instead, you can just type in expressions like 2 plus 2. Or, sorry, you have to print it out. Do that, it's 4. Now, you may be wondering what I just did here, this whole print line thing. That's just called a function call, and it's just going to print out whatever you put inside it. And so you don't need to worry about that for now. So we're going to cover some basic things. First off, we're going to cover simple numerical expressions. We can do these things like addition, which we saw earlier. We can also do subtraction. And then we can do multiplication using the star. Division using a slash. We can do powers using the caret. Finally, we can use modulo using the percent sign. But what else can we do besides numbers? Well, JPizza supports a wide variety of primitive data types. It also have things like booleans, true or false. And that just allows you to represent a expression, an evaluation of an expression, whether it's true or false. So we do like we can later on do things like is 2 equal to 3, and it'll return false. and we can use that to execute code based on if it's true or false. We also have what's called a string. A string is a string of characters, like hello world. We can do that. We can represent it by using quotes. For example, if we use single quotes, we have to end it with a single quote. But if we use double quotes, we have to end it with a double quote. Now you may be wondering, how do I include quotes inside of a string? We can do this by escaping them using the backslash. When you use a backslash, it registers special characters or skips the character it's prefixing. In this case, we can include backslashes by include the quotes by escaping the quotes in there. And that works. The final two data types we'll cover, which aren't very important for now, are lists and dictionaries. A list is defined using square brackets, and you put elements inside of it separated by comma. You see, we have each element printed out. The dictionary, it's sort of like data storage. You can put a set of keys and values where each key is mapped to a value. Then you can later access it. We'll be covering these two data types or collection data types in more detail in the future. For now, we can just ignore their existence. We don't care about them for now. Now, finally, to cancel off this section of the shell, let's see how we can type more than one expression at a time. In JPizza, each expression is separated by a semicolon. However, in the shell, it automatically adds a semicolon to whatever you type. You can still separate things with semicolons, though. In this example, it prints 2 plus 2 and 2 plus 3, which ends up being 4 and 5. Now let's run some JPizza. Now, you can use any text editor to create a JPizza run file, but I'm going to be using VSCode because it has an extension for JPizza code. To install it, you go over here to Extensions, and then you can type in JPizza. And here we have the beautiful language support for it. So to create a new file, you want it to end with .devp. So let's just create a main.devp file. Oops. We all make mistakes. Now, if you're using VS Code, this will enable the syntax highlighting for JPizza. Now, the first thing we're going to want to cover is what a variable is. With a variable, you can essentially assign a value to a name. This allows you to reference a name during the program, and then you can change the value of the variable later, and when it accesses that name again, it'll be the updated value. To create a variable, we start with the var keyword. Then we want to follow it with the identifier, or the name of the variable. In this case, I'm just going to make it x. Then we use an arrow to tell what the value of the variable is. However, you actually can omit all of it and just have var and then the variable name. This assigns the value to null. Null is the absence of value. It's just nothing. When a variable has the value null, it doesn't have a value at all. Now, I'm going to write in a comment null next to this so we know what it has a value of. If you want to know what a comment is, it's essentially lines of code that the compiler just completely ignores. It doesn't matter what you type in here, it won't be acknowledged by the program. So let's try printing out x. So let's save. Now you may be wondering, but how do I run this JPizza code? Well, you're going to want to, go into a terminal and go to wherever your program is located. Then all you have to do is type JPizza and then the name of your program. And voila, it prints null because the value of x is null. Let's give x a value though. Let's use the arrow and assign it to 2. Let's run JPizza. And now it says it has a value of 2. What happens if we change the value of x? To change the value stored in a variable, you do the exact same thing as above, except without the var keyword. Var tells the program that you're making a new variable. However, if you just write the name, arrow, and then the value, that is actually that's not creating a variable at all. It's just assigning the value of a variable. So I'll just write 3 after this. Oh, I told you what a comment is, but didn't describe how to make one. You can make one by typing this diamond shape, and then anything after that on the same line is classified as comment. You can write a multi-line comment just by writing these 2 arrows, and then anything in between those 2 arrows is classified as comment. This also allows you to do stuff like this, because it cancels the comment, but that's kind of weird, so I don't recommend doing that. Anyway, let's print x again. And look at that. That's how variables work simply, but there's some more that we can do with it. What if you want to add 1 to the value of x? Well, you can do x is x plus 1. That works. But that's kind of annoying. Instead, what you can do is x plus equals 1. This works for a lot of different expressions. You can do minus equals, times equals, divided by equals, power equals, modulo equals, and it's all recognized as valid. It's all shorthand for if you have some variable x and you have some operation y, then x, y equals, and then some variable z is the same thing as doing x equals x, y, z. If that made sense. It might be a little overcomplicated for this, but basically just know stuff like x plus equals 1 is the same as x equals x plus 1. However, when we're dealing in terms of ones, we can make this even simpler. We can just change this to x plus plus. X plus plus increases the value of x, and x minus minus decreases the value of x. If we do this, it does the exact same thing. If we want to decrease it, x minus minus. This is known as incrementing and decrementing, and it's incredibly useful in a lot of scenarios, especially loops. Now let's cover conditional programming. I talked about this a bit earlier with Booleans, but now we're going to see how you can actually do this. The first type of conditional I'm going to talk about is a query. A query allows you to return a value in an expression based off of a bunch of different conditions. So the first query we're going to write is going to take in some user input. And we can take in input by just using this function called field. And then whatever we type in here will be printed before the user's input. So if we type, please input something. Now if we run this, give this please input something. Now hello is now assigned to x, but we don't see this, so I'm going to print out x. And so what we're going to do is we're going to rate a number that the user enters. We can do this by putting in before field. And now this is a cool function that gets a number only. You can see if we type all these different things, it doesn't work, but as soon as we type a number, it's fine. So we're going to rate this number by doing some cool conditions. I'm going to create a variable called rating. Let's see. Let's say if x is greater than 10, it's a really cool number. So what we can do is if x is greater than 10, let's use this greater sign. And we're going to have to put a question mark before it to indicate it's a query. Now if we have basically if x is greater than 10, colon, and then the value. Really cool. And right now, this is really all we need. So we can print out rating. Type in 11, really cool. But what happens if you type in anything else? False. That's strange, isn't it? This is just because it returns the value of the last conditional. So to prevent this, we're going to add some more conditions. The first one is just going, my tab key is not working for some reason. Fixed it. And so we can do this by using the $sign. If we do $sign and then another condition, like x is greater than 5, and then another value, it'll go to the next condition if this one is false and check if that's it, and then return that value. Let's try this now. What if we put like 7? All right. Or 12. Really cool. But what if we put in something that's not greater than 5? It just gives false again. Now, the way we're going to fix this is by adding a default conditional. We can do this by doing a $sign and underscore. This tells it just, okay, that's the last condition. If all of these are false, then do this one. Try this now. Let's see. Oh, I accidentally put a semicolon here. So the reason this doesn't work is because the semicolon says this is the end of the expression, and it sees this one as the beginning of the next one. But really, it's all the same expression. So I need to remove that. Let's try this. Let's type 5. Not so good. 8. All right. 15. Really cool. But it seems kind of useless to assign this to a value. Instead, we could just go through and print the different ones based off of if it's true. Now, we're going to switch this over to what's called an if statement. An if statement uses the format if condition, that code else code. And if you want to write more conditions, you can use else if. However, JPizza has this really nice shorthand syntax, similar to Python, elif. So instead of having to write else if, you can just write elif for another condition. So you do elif condition code. And any branch after if is completely optional, but it's useful if you want to write multiple conditions. So if condition, then runs the code. Otherwise, you can have as many elif branches as you want. That just runs if the previous one was false, it checks if that condition is true. And if that's true, run the code. And finally, you can have an optional else branch that says if everything before it was false, run this code. So let's go back to our ratings. We can do if x is greater than 10. We can print out really cool number. Elif x is greater than 5. We can print out, all right. And finally, else, print line, not so cool number. Take that. Let's try this now. 5, not so cool number. 8, all right. 15, really cool number. So yeah, it's basically just going, okay, we have the number, let's say 5. Is 5 greater than 10? If so, we're going to print out all this. But it's not, so we're going to go to the next one. Is 5 greater than 5? No, it's equal to 5, so we're going to skip this code. Finally, this is just automatically true, so we're just going to print out not so cool number. If we have 8, however, is 8 greater than 10? No. Go to the next one. Is 8 greater than 5? Yep. So we're going to run the code inside of these curly braces and then skip all the way to the end. We've got one final way to do this, and this is called a switch statement. Now, what the switch statement does is it allows you to write a bunch of different cases and check if the value you're comparing is equal to any of those cases. That seems a little bit confusing, but I'll show it to you in a second. We're going to write a switch statement that tells you if the number you gave it was even or odd. Now to write a switch statement, you're going to do switch and then in parentheses the value you want to compare. To write a case, you do case space and then the value you want to compare x to. In this case, we're going to do 1 and then a colon. Now you may be wondering, why is it using a colon instead of curly braces? This is because switch statements have fall through. Fall through essentially just means that it's going to go, and if a case is true, it's going to keep running every single case below it until it reaches the keyword break, and which is going to leave the switch statement. This is useful if you want to test for multiple conditions like this. So we're going to have case 1, case 3, case 5, case 7, and case 9, in which all of these numbers are odd. So we're going to print out odd. And then we have to break. So if we enter 3, it's going to go, okay, 3. And then it's going to go all the way down through these until it reaches code. And it's like, oh, we got to print out odd. And then it breaks out of the switch statement. Then we can do 2, 4, 6, 8, 10. And we can print out even and break. But what if they input something that's not in here? Well, then we can use default. And then we can print out like, unhandled. And so it's just going to go all the way down. If we had no break statements, it would go the code in 1, 3, 5, 7, 9, 2, 4, 6, 8, 10, and then default. Now, we got to do something here, which this is a special case for JPizza where every single all code must have at least one expression. It must have some code in it. So what are we going to do here? Because each one of these has to have some code. Well, we could do something like just write 1 for all of these. However, in this case, what I'm going to do is I'm going to use this special word called pass. This essentially just says, skip this, it has no code. So if we just write pass for all of these empty conditions, just like that, then we don't have to worry about any errors. So let's save and test this out. Input 5 is odd. Let's input 8, it's even. Let's input 15, it's not any of these, so it's unhandled. And so if to demonstrate the fact that it'll keep going, if we remove these break statements and say like 8, it'll say even, but then keeps going and says unhandled. Same if we say like 5, it'll say odd, and then keeps flying through, and then it hits even, and it keeps flying through, and it hits unhandled. So we need these break statements. There is another form of switch called match, which actually returns a value. However, that's a little more complicated as it supports something called pattern matching, like that. Well, and that's a bit complicated, so we're not going to cover that just yet. Now let's learn how to make some loops like this. Now the first loop we're going to cover is just going to be the standard loop. It's just loop, and it runs all the code inside the curly braces infinitely. And I should clarify for anyone that hasn't programmed before, a loop is just a piece of code that repeats until some condition is met. So let's make it do something. Let's create a variable x and set it to 1. Then we can just print out x and increment it inside the body. So that should just infinitely print out increasing numbers. And let's see if this is true. It is, but this code will never exit. So let's use the break statement. Break exits the body of a loop, and we can use this inside of an if statement. But first, let's just see what happens if we just put it there. Yep, it exits. But if we just put an if statement, like if x is less than 100, greater than 100. So this will run all the way up until x is 101, which will be, we print out 100, add 1, 101, and it's like that. It exits. So we can actually make this simpler by using what's called a while loop. We basically just change this up here to while, and then some condition. And what this will do is it'll keep repeating what's in the body while this condition is true. So this should give us relatively the same output. Let's run it. And we see it only goes up to 99 because as soon as you hit 100, that's no longer less than 100. But it's basically the same output. And this is actually faster than the standard loop because it has to do less operations. Where this one, it knows that it's just the while loop. The other one, it does the loop, and then it has to do the if statement and other stuff. So this is technically faster. However, we can make this even faster by cutting out this and this, not the semicolon. This is called a for loop. We do for and then a variable, an arrow, your minimum value, and your maximum value. And this will iterate this variable. It'll run the code and assign this variable starting at the minimum value and step up by 1 every single time until it hits the maximum value, in which it'll no longer run. This should give the exact same thing as before. Yes. Just, it's not, you can't tell, but it's faster. It's just a lot cleaner and shorter and straightforward too. However, what if we want to increment at something that's not 1? So let's list off all the numbers 1 to 10. Sorry, 0 to 9 technically. What if we want to list off them in half steps? Then we can use this little operator right here after our range, which allows us to specify the step. Then we just put the step afterwards. Let's run it. Look at that. It goes up in half steps. Now we've got a few more loops. The first one, well, technically not the first, the fourth, but the first new loop I'm going to show you is the iterator loop, which takes a value out of a list. You still use for, but then you use this backwards arrow, and then you put a list afterwards. This can be a variable, it can be anything, it doesn't have to be a list created right there. What it's going to do is it's going to go from left to right and iterate over it. It's like if you were to do, use multi-line comment right there, like I0, then while I is less than the list size, item is equal to list I, and then I++. And then you have the loop of the body here. However, this is faster and a lot shorter and a lot nicer. So let's just print out each item. Yeah, 1, 2, 3. Makes sense. And the final loop we're going to look at is the do while loop. Do while is similar to a while loop, except it checks the condition at the end, not the beginning, which means it'll always run once. This allows us to do stuff like, I don't know why you do this anyway, but while false, print like high. And this will run once, but then it says it's false, so it breaks. So we can do what we did earlier, the while x is less than 100, except this time it'll hit 100, because it won't check until the very end. Well, wait, no, but however, it'll start, yeah, no, wait, never mind, but it does have to run at least once. If we set x to like 105, it would still print out 105, whereas the other one wouldn't. So there are some more advanced loops, but to first understand those, we should understand lists better. A list is a collection of elements. You can just create one using like 1, 2, 3, 4, anything separated by commas inside of square brackets. You can have lists inside lists as long as they've got commas after them. You can have anything inside a list. And lists can be mutated, which means they can change. You can use functions like append to add items to lists. And there's this little shorthand in JPizza where if you do like something dot some function and then call it, this actually turns into, it's compiled into some function of something. So we can change this just into this. And so we can print out our list. And you see we've got 6 is now in there, but it's not in there originally. We appended to it. Now there's a ton of list functions and stuff you can do with them. You can find them in the documentation under the native functions, I believe, but I'm not going to be covering all of them. Really what you need to know about lists is that we can construct them using loops. If we have some loop, like if we want to get a list of all the values, the numbers 0 to 9 in half steps like we did earlier, you might think you do something like this, where we do the same thing as earlier, and then just append the item. And sure, this works, but there's a faster, nicer way of doing it, in which what we actually do is make this the body of the variable. This is the value. Instead, we use this fat arrow and give it a value afterwards. And this can only be applied to variable assignment, by the way. You can't do this in any other scenario. So you can't put this as an argument just because it messes up a bunch of the underlying code. But if you send it to a variable beforehand, you can pass it in. So this will end up generating a list of every single time the loop runs, and it'll add the value after the arrow to the list. So let's try this again, and you see it works. Now I'm going to shorten this to like 0 to 3 so I can show off what's happening. Basically what it's doing is it's going, okay, I is 1 in this scenario, or 0. So we're going to see what it returns with 0. So we're going to add 0 to the list. Now I is 1, and it returns 1. So we're going to add 1 to the list. I is 2, returns 2, we add 2 to the list, so on. So really, that's all that does. It's just a really fast way and short way of generating complex lists like that. It can be very useful in some scenarios. But those are the 5 types of loops, a more in-depth look at lists, and a way to generate lists using loops. So now let's look at everyone's favorite part of programming, functions. Functions allow us to repeat code very quickly and easily and safely. Now imagine this. You've got some function that converts, well, you've got the equation that converts Fahrenheit to Celsius. You could keep typing it out every time you want to convert it, or you can put it in some chunk of code where all you have to do is give it the number and it'll automatically put that expression in there. That is exactly what a function is. It runs the code with the variable values you've given it. Now let's see how to create a function in JPizza. First, you start off with the fn keyword. Now let's make a function that takes 2 values and adds them together. You do fn, then the name of your function. Then you want to add these angle brackets. If your function takes no parameters, you don't add any angle brackets. Otherwise, you do. Inside of these, you want to put the names of each parameter, and these will be what are passed in to the function. Then that's how you access them. When you call f of x, x is just the placeholder for it. You might recognize this as like from algebra. So if you have function add, And let's do A and B. We've got numbers A and numbers B. Then we put braces, and inside of here is where we have our body, where it does all the math. Now let's create a new value C. So var C is A plus B. Now let's return C. To return a value is to stop the function and give back the value you want it to simplify to. So we can just return C, and now it will exit out of the function and give the function call a value of C. So we can actually simplify this similar to a language called Rust. If the last line of code just doesn't have a semicolon, it'll return that value. So that is the same thing as return C. However, we're just going to keep it as return C for clarity purposes for now. So let's try printing out like add 2 and 3. Look at that. It gives us 5. Now this is pretty cool. We can write any code in here using these placeholder variables, and it'll just work when we call it. See, 2 gets substituted for A, 3 gets substituted for B, but we can actually simplify this. Functions have this arrow shorthand where instead of doing like return A plus B, you can actually shorten this and just use this arrow, then A plus B. And what this does is it basically returns whatever's on the right side of this arrow. So if we just run that again, it's the exact same thing. Now that's pretty useful if you're making a small function like add, or if you have some add one function. You don't want to have to write all of this extra code just for that. So you just do x plus 1. And then do add 1. Oops. And look at that. It adds 1. Who could have guessed? So we're going to be using this in the next section, in which you're going to build a number guess game. So in this section, we're going to be creating a number guess game. And it's going to be using basically everything from the last few sections. Yeah. So the first thing we're going to want to do is get our random number. Now, there's this function called random, which is pretty useful for generating random stuff. So let's just print out the value of random. And you see, it gives us a random number between 0 and 1 each time. Now, that's not very useful because no one wants to guess 0.3716369071192. However, you can use rand int, which takes a start and an end and generates a random number in that range, just like that. Look how much better that is. Now we can generate a random number 1 through 10, and apparently 11. I'll look into that later. But let's see. Let's assign this to just a value number. Yeah, var number is random 1 to 10. Now let's create a function called getGuess. And all this is going to do is it's going to take input from the user, a number input, and return it. And it's just going to prompt the user like guess a number 1 through 10. And so this isn't going to take any parameters, so no use to put any angle brackets. So I'm going to put that skinny arrow right there so we can automatically return it. Then we're going to use the in field, which stands for number field, because the default input function is field. Number field gets a number only, automatically handles all the annoying stuff that you normally have to do. And then just say like guess a number 1 through 10. And this will be displayed to the user. So let's try doing this. And so we can guess the number 1 through 10. And it'll tell us if we guessed it. And apparently it really is not 5. It's gotta be 5 eventually. There it is. Okay. yeah. So we can build on this by giving the user feedback on the number. So in order to do that, we're just going to use a simple if statement. So what we're going to do is we're going to say if our number, well, first we're going to assign our guess to a variable, just called guess. So if our guess is greater than our number, let's say too high. Otherwise, if our guess is less than our number, we're just going to say too low. And finally, this means that our guess is our number. We're going to print good job. And then let's type return. Now this is going to do nothing for now, and it's going to break, but you'll see where we're going to do this in a second. So let's do this. Oh, that's because of that. To do that, we're getting feedback on our number. And eventually it will be 5. Eventually it'll be 5. Yeah, like that. So it doesn't break, but it's not really helping anything. But the reason we're going to do this is because we're going to wrap this in a loop, just like that. And really, we can just remove this return, which should be a break, but we can just do while guess does not equal number. And up here, we can just type var guess. So it's already initialized. It's like that. Do 1, 2, 3, 4, 5. It's too low, it's 8. Too high, no, 7. Good job. Just like that. But what if we want to play multiple games at the same time? This is where we're going to wrap this in a function just called game. Like that. And then we can just indent. Then what we can do is we can just loop and then game. And we're going to have infinite games. We can guess. Good job. Now it's a new number. But actually, it's not a new number because we need to move the number generation code into here too. But now as soon as we do that, too high, is it 1? Yes. Too low, yeah. And we can do one final thing to make it a lot nicer. I believe the function is called clear. And this is just going to clear out our console. Like that. And so that just helps make it look a lot more organized and sort of tell the person that, yeah, you have won the game. Now you can add extra stuff like let's say we can wrap this in a do while loop, and then we can just get an input, press enter to play again, and then if they just press enter, it's going to be nothing. If they press enter to play again, we can just play one game, and then test it after that. So if we try that now, 5 too low. Oops, I went lower. Anyway, too high, 6. Good job. Press enter to play again. Do anything else, it's going to exit. Otherwise, too low, too low, too high, too low, 7. If we just press enter, we get to play again. Look at that. It works perfectly. You can expand on this. You can make it so they can enter a custom minimum and maximum value. But yeah, that's really it for the number guess project. Now let's cover type safety and static typing. Now, what is a type? In programming, a type is what class a variable fits into. If we have like 2, that's a number type. If we have the string, it is a string type. If we have a list, it's a list type. Static typing basically says every variable has a set type and it can't change. This is useful for safety reasons so that you know exactly what a variable can and cannot do. Now, natively, JPizza is dynamically typed. Do var x equals 5, and then x is a string, and then x can become a list. However, this can all change with one simple addition. If we use a colon and then a type afterwards, we statically type x to whatever we put after it. You can also use the hash symbol, but a colon is more readable. However, the hash symbol is what is supported on the VSCode extension for the time being. So this will actually fail if we run it because the 5 is not a list, obviously. So let's try this. Let's just go course, main, and then the run flag. And yeah, expected list but got num. However, if we put this here and kind of like swap these two, then we got string but it expected a list. And if I just delete this line, it got a num but expected a list. Now, that's good and all, but we can also implicitly type things using let. Let is similar to var, in which we don't have to say the type. However, it'll automatically statically type the variable to whatever value it is assigned to initially. So if we do this, we get the same error, but we didn't even specify the type. This is really useful when you want to write some safe code, but you don't want to have to manually write out all the types. And it's a really nice alternative. You can also statically type functions. Since we have our function add1, returns x plus 1, we're going to print out add1 here, like that. That's cool. But it can easily break if I just wrap this in parentheses. Then it's 1, 1. We don't want that to happen. So instead, we can say that we want x to be a number by using colon num. And once again, hash works here, but colon's more readable and more standardized. We look at that and it says expected type num, but got type string. So we can just delete the quotes and it'll be happy again. Something else we can do is we can use several different ways to say what return type what type the value that it returns should be. We can use a colon, then num. We can also use yields num. And we can also use equals num. I'm going to be using colon num for now. And if we try this again, it's going to work fine. But let's say we remove this, but let's wrap this in quotes. Then expected num but got string because quotes 1 plus 1 is just a string that is 1, 1. And that's not a num, so it gets mad. So instead, if we just reset this to 1, then this is perfectly safe. Now, what if you want to be safe, but you want a function to accept multiple values? That's when you can use a generic type. Let's just have a function called myGeneric. It's going to take an x, and it's going to have a type of t. And you may be wondering, what is t? Well, if we put in parentheses t afterwards, what this is going to do is it's going to allow us to supply a type, sort of like a variable. And then whenever we use t, it is just going to substitute with whatever whatever type we supplied. And in scenarios like this, where the compiler can actually go, if we don't give a type t, but we do give it x, it goes, okay, so t must be the type of x. And so it can do that. So what we're going to do is I'm just going to do like var y with the type of t is equal to x plus 1, then return x, and then we can also make t like yields t, like that. So everything has to be of type t. So then let's print out like my generic, and let's just say 3, And if you want to explicitly tell it what it's going to be, then in angle brackets at the end of the call, you type out each generic that corresponds to this. So it's kind of like flipped. When you're defining a function, you have angle brackets around the arguments and parentheses around the generics. When you're calling a function, you have parentheses around the arguments and angle brackets around the generics. So let's save. Look at that, works just fine. However, if we give it like string, it gets mad because it wants a type of string like we supplied here, but it got a type of number. Then we can just keep like remove that, and it gets mad because the string 3 plus 1 is equal to the string 31, which is not a, well, sorry, 3 plus 1 is 4, which is not a string, so it gets mad there. But finally, if we remove that even more, this should be returning y. Then it gets even more mad because it's supposed to be string t, but it got number. But then we can just control Z, all that. But since it can infer it from here, we actually don't even need to supply the type there. We can just delete that, and it works fine. Whereas if I didn't have that, it would get very mad at me, saying that generic count error, which means we need to supply a generic. But if we just put in angle brackets num, it works fine. Now all this static typing and generic typing is very useful if you want to write some safe code. And there are some things that we'll cover later, like how to make a list that is only one type. So like to statically type a list. Because right now if we assign something to a list, like var list has a type of list. But we can also do for like that. And then later that might lead to some issues. So later down the line, we'll see that we can do like array of num and then some stuff. So we can only do that. But then if we do that, it'll get mad at us. But we're not quite there yet, but that's a good example of where generics come in. All right, now we're going to cover some more like advanced function techniques. So we're going to be covering how to do default arguments, an infinite amount of arguments, keyword arguments, and then decorators. So let's start with default arguments. They're exactly what they sound like. They are an argument that is the default if you don't specify it. So to do this, you just add an equal sign after an argument and then the default value. So I've got this add function, and the default value of b is 1, and then it's just going to do a plus b. So if we print out add, you typically have to use 2 arguments, just because, you know, we've specified 2. So it prints out 4. However, if we can delete the second argument, and it just substitutes 1 in. Now you can't add like another argument that doesn't have a default value, because there's no way to then set this while keeping this default value. So this has to have a default value. Now let's look at how to accept an infinite amount of args, or better known as var args. Now you can simply use this using the spread operator, the dot dot, for your argument. And it has to be the last argument, because you can't accept more arguments after you accept an infinite amount of arguments. So let's create a like my print function that prints everything we give it, and we can give it an unlimited amount. So I'm going to do dot dot args. It doesn't have to be called args, but args is pretty standard naming convention for it. Then if we just print out args and see what gets passed in. Now let's do my print 1 2 3 4. You see it passes in a list of every argument. So what we can do is we can do for arg in args, and then let's just print arg. And so you see 1 2 3 4. They all get printed one after another, and we can even put more in. And something that's useful when dealing with this is that this not only specifies variable arguments, but allows you to spread a list into a function. So if you have a list of arguments like 1, 2, 3, 4, like earlier, we can use the spread operator like that to pass them in as arguments. And this includes if we like accept A, B, C, D instead of an unlimited amount, we can still spread these in. And then if there's less, gets mad. There's more, gets mad. But yeah, so these can just be treated like a list of arguments, and you can just drop them in there like that. This allows you to do cool stuff like accept a function as your first argument, and then the arguments you want to pass into the function to use higher order functions, and then you can spread the arguments into the function to call it like that. Now let's look at keyword arguments, better known as kwargs, because KW, keyword, and then args. This is indicated with like the backslash operator, where if let's do print kwargs, after all of your arguments, you got A, B, C, you use backslash, and the name of what you want your kwargs variable to be. So I'm just, I'm just gonna accept no arguments and just have kwargs. And so then we can just iterate over the keys. Well, I should probably show you what kwargs is passed in as and how to call it. So do that after you just give it all your arguments. Use a backslash, and then you can do like hello world b2, and then like foo bar, or like you can do like foo bar baz. It's just an identifier colon then that. So let's see what this gives us. So I don't know why that took a second, but yeah, it's working now. it just cold start with Java, Anyway, that you see it passes in the identifiers as strings, and it creates a dictionary from that. Now, dictionaries are similar to lists, as in they're just a collection, except they've got a key and a value, and each key is unique, but you can have duplicate values. And there's a bunch of functions that you can do with them, but I'm not going to cover them because you can find them all in the documentation. Just know that they're similar to lists, except each item has a value. And you can access an item by using its key instead of its index. If we convert a dictionary to a list, it gives us the list of its keys. So we can do for key in the kwargs list, and we can just print out on our new line key and then kwargs key. And that's not exactly what we want. So I'm not sure what happened. It seems to be working now. So if you run it, see it. What the heck? Okay. If you run it, it seems to be working accordingly. It prints out the key. Hello world b2 foo and then bar and baz. So those are how you can accept some more advanced arguments into the functions. But there's this really nice concept in functions called decorators. Now, a decorator is a function that takes in a function and returns a new function. It can be used to add code in between function execution automatically. This can be really useful for things like APIs. So you can just put a decorator before a certain function that you want to execute like on an event, and it'll work. So to create a decorator, let's start by creating a new function. Let's call it my decorator. And all this is going to do is it's just going to take in a function. So I'll just call the input func. We can't actually use the word function because in the original version of JPizza, function was the word used for declaring a function, and it still works. It is still valid syntax. However, fn is standardized, but function is still a keyword that is used to declare functions, just for alternative syntax. So what we want to do is we want to return a function. So we can do this by creating some function. Let's just call it inner. And let's use our spread args to accept as many args as we can. So then we can pass them in to this func call. Just like that. So when we call inner, whatever args we put in there will immediately be passed into a call to here. But just for the fun of it, let's print out the arguments before we call it. Let's create a new variable called val. And let's print out the value and then return it. So what this is going to do is it's going to take in a function, and it's going to return a new function. Then when you call it, it prints out the arguments, then it runs the function you gave it, and then it prints out the return value, and then it returns it. So then we can return inner. We can actually shorten this using lambdas, which are anonymous functions or inline functions. Basically copy this and then just put an exclamation mark, and then it allows us to return a function like that. And this exclamation mark basically says this function has no name, so it allows us to create it as a value and assign it to variables and stuff like that, which is very useful. And this even allows us to shorten this further by, you can just change that to an arrow like that. And voila, we now have a very short decorator. So now we can create a function like add1. And the way we can apply this decorator is by doing /, and then the name of the decorator, my decorator, and then another /. Now let's do add1 5. So you see, it prints out the arguments we gave it, which is 5, and then it prints out 6, which is the return value. And you can see that this is being printed out by the decorator. If I wrap it in print, it gets printed twice. So that's pretty interesting. And you can do some more fancy stuff when you like return, args, and then doing like a join. And then return value, and appending the value like that. And I'm going to wrap that in parentheses. So then if you pass in more, scale is just the same. So yeah, that's how to use more complex forms of functions. And we'll be covering enumerators next. So now let's cover enums. Enums are essentially a way to automatically define your own keywords. They're kind of a more abstract thing to explain, but they're very useful in scenarios in which you want to be able to accept things like multiple types in one scenario, but you want it to still be statically typed. Or if you want to accept a bunch of different values or have a bunch of different states, and you don't want to type out each variable for each state, then that's when you can use an enum. So going off of this state idea, let's create some enum to represent the state of the toppings on a pizza. Let's create an enum with the enum keyword, and then we just type whatever we want it to be called. And so toppings, then we use curly braces. Now we can define the word for each topping inside of here. So let's start with maybe sausage. And it's typically good convention to use all uppercase letters for each element. It's typically standard convention to use all uppercase letters for each element. So then we can have like pepperoni. And finally, let's do pineapple. And this isn't really a topping, so that's what we're going to do in a moment. We're going to make fun of anyone that is insane enough to put pineapple on their pizza. And I'm sorry if anyone gets offended by this, but you should, and you shouldn't be given the knowledge of this programming language if you enjoy pineapple on pizza. You don't deserve it. So let's assign one of these enum values to a variable. So we can do variable And then let's just call this favorite topping. And we can give it a type of toppings like that. And it'll have to be from this toppings enum. So that we can just grab one just like that, using this double colon operator to access this value. Then we can print it out, and you'll see something strange if we try to print it out. So let's try and do that. Not sure what happened there. Spoiler alert, I'm an idiot, and I forgot the run flag -r. So now we see it prints out toppings, but then instead of saying sausage, it says 0. This is because when we get the element, it doesn't actually know the name of it, it just knows the value. And the value of sausage is 0. Now, if we try and do something like see if it's equal to 0, it'll say false. It has to be equal to this and this only. Like that. So it allows us to create a custom sort of keyword, a custom value that we can use compared to doing like const sausage is 0. Pepperoni is 1. Pineapple is 2. That gets really annoying when you have a lot of them. So just doing something like that, very quick and simple and easy and nice and cool and adjective. So let's get into some more complicated enumerators. The first good one is public. If we put the postfix pub after enum, then it makes all of these elements public. Now I believe we can still do this. We can just remove the colon and the whole toppings, and it'll just be put into the global scope. It's very useful when you don't want to do that, when you want to have something nice and quick. And so that's pretty useful, but let's write some actually used code. So we can do this by, let's switch our favorite topping, which we can do. Let's have case, and then since it's public, we don't have to worry about doing that. We can do case sausage, and say like print light. Okay, cool. So this will be a good review of switch statements too, because we're going to add another case for pepperoni. Pepperoni. And it's just going to do the same thing. But if you have pineapple, we're just going to print out ew. Yeah, no, that's it. Then just to really give it that extra mile, we're going to use a library to crash the program. And you might not know how to do that, but we can just pretty easily just do import sys. This will import the sys library, and it allows us to have a bunch of system-based functions. So I'm going to just do sys : exit, and let's just type in 1, and then we don't even need to do a break after that. So then we can run it. Okay, cool. Pepperoni. Okay, cool. And if we do pineapple, ew, and you didn't see anything, but if you run this in a terminal or something, it'll say it crashed, and it'll get really sad, and it'll get really upset. And so that's good, because, you know, it's pineapple on pizza. What are you doing? Come on. But we can actually go further with our enums, with enum properties. And enum properties essentially allow us to create holders of types under like an enum. And that might sound weird, so let's start off with a very simple one called option. Create this by just creating a public enum option. Then we're going to have sum, and then we're going to make this an enum property. So inside of these curly braces, that's where we put all of our properties, and we can also type them. We have some value, and then we have none. And we can set value to like a type of any, but that's already implicit right there. So we've got our sum, which holds a value, and then none. So we can do like let x and then we can just do sum, and we'll call it, and the parameters will be assigned in ordinal order. So the first one gets assigned to the first property, second one's to the second property, blah, blah, blah. Let's do sum 12. If we print out x, we see we get option, which is different than before. Because now we can actually print out like the value of x. If we do val, we get this property stored inside here. And you may be noticing a pattern, and that is the fact that the double colon operator brings properties out of objects. This will be useful when we cover these things called classes, and we'll also be covering things like structs, and then libraries eventually. That was a little teaser previously. I just really wanted to do that because, pineapple. I don't think I've fully expressed my hatred for it yet. That's not important. Because what is important is what we're about to do with pattern matching. Pattern matching essentially allows us to say if the variable we give it fits something, then any unknown variables we give it will be plastered and resolved, sort of. You can think of this as, let's just write an example. Let's match x. We want to get the 12 out of our sum. So we do sum val, and then we use the skinny arrow, and then we write whatever we want to do. So let's just print out value, and then we use a semicolon, and then none, and let's just print out is none. Now, what do you think it's going to do? It prints out 12. What this does is it says, okay, it's sum 12, and then it looks at our pattern, sum val. Let's think, it thinks, how is this going to work? Well, we have, it's a sum, so that works. And then it also has a parameter called val. So let's take out the parameter called val. Now you can also do the name and a colon and then whatever you want to bind it to. So if val is element op, it'll say, wait a minute, element op isn't anything. So we're just going to assign val to element op. And that works too. But if there's no colon, it's just shorthand for itself. This essentially allows you to check properties of objects and their types all wrapped into one neat bundle, along with bringing out their properties like that. It's a lot easier than doing, well, actually, you can't check if X is an instance of sum. You just have to have it beforehand. But this allows us to do things now, like if we can also make it none. This allows us to do things like accept a type of option. So we have to handle each null case explicitly. This is useful so people can't just pass null into your functions and then just have a break. As a matter of fact, when we get to packages in the standard library, we'll see that option and box are built into the language, but we're not quite there just yet. So those have been enum properties, public enums, basic enums, and then pattern matching is a bonus, which we'll get to later, but this is basically all you need to know about it. And yeah. All right, now that we've covered what an enum is, we can gradually work our way up the object spectrum, and we can look at structs. Now, a struct is a way that allows you to quickly store several data points and just like different values. You can think of it as like a table, and you can keep making more of these tables very easily. Let's start off with just the struct keyword. Now let's make like a vector3 struct. And if you don't know what a vector3 is, it's simply a vector that holds 3 coordinates. It's like a 3-dimensional point. You have x, y, and z. It's used a lot in like game design and stuff. So you can hold positions and like different powers and other things. I should clarify by powers, I mean like velocity and other stuff. So in order to create entries, we can simply just put down the name of like the field. So we can have x, y, z, just like that. So now what we can do to create a new vector3 is just simply, you might recognize this from enum properties, call it like a function and pass in the parameters in order. Now we can do like print, oopsies, the x of the vec, and let's try this. 1, print y, 2, print z, 3. Now that's basically all I can do with these. They're their own type, just like that. And you can simply put these in. Then, if I'm correct, you can use the colon to statically type them. Or no, you can't. The one downside to structs is that you cannot statically type them. So that's better for enum properties or our next subject, which is classes. So with enums, enum properties, and structs, we've been slowly building up to this point. We're going to reveal the big thing that is classes. Classes are sort of like templates, and then objects are parts of that class that have been filled in. They're instances. The class simply just provides the outline for us. So to get started, let's create a pizza class. Give it the class keyword. This can also be replaced with object, short for object. It does the same thing. And then there's also traditional JPizza recipe, which was the original keyword. But class is the most clearest. Object can be used if you more specifically mean it as a sort of object that should be instanced, but class is more general because of attributes and other things that we will be going into. So let's start with attributes. Attributes are fields in the class, just like in enum properties and structs, except we have a lot more freedom with them. First off, we can make them private or public with priv or pub. Now, by default, they are public. And what does private and public mean? Well, private and public means whether they can be accessed from the outside or only on the inside. If something's private, then you won't be able to do like my class : private attribute. It just won't let you because it's private. It's hidden from the outside world. However, if it's public, this is perfectly valid. So let's create a public field, and that's optional. You can just type out the name of the field, which will be called topping. We can statically type it using a colon, so let's make it a string. Otherwise, we can just omit this. And then we can also give it a default value by using the arrow. And so we can set it to like sausage, or we can just set it to null, which is the default. And then we can also declare multiple on one line, like topping, crust, cheese. However, if we declare them all on one line, we can't use any of the more advanced modifiers. So let's make topping public string. Now let us make cheese, which is going to be private. It's going to be a string. Same with breading. And let's change cheese to cheese stuffed. Let's make it a bool, like that. So topping can be accessed easily, but cheese stuffed and breading cannot. And let's swap these. Let's make this private. Let's make this public. Okay. So now we're going to cover the constructor. Now the constructor is defined with the ingredients keyword because, once again, originally called a recipe because it is pizza. Ingredients is a function that has no name, and it is essentially the function called when you instance it. Like when we do let my pizza equal to pizza, like 1, 2, 3, A, B, C. It's really calling the ingredients function of the pizza on a new instance of the pizza and then returning that pizza. So we're just going to take in a topping, bread, and cheese stuffed. And we're just going to automatically set this to false by default. Now, you may notice the fact that we have the same name for both of these. So how are we going to differentiate? Well, we have this keyword called attribute, or just attra, and we can use this to differentiate between whether we're assigning the attribute or the variable. So if we assign the attribute topping to the variable topping, this has priority over this, and this with attribute takes priority over this. So this sets the attribute topping to topping. However, in the case of breading, it's just called bread, so we can just do breading is set to bread. However, if we do use attribute, it does make it a bit clearer. This is also applied if you want to access it. So we can also access attribute topping. However, what is a bit nicer is we can use this keyword, which passes us the current instance of the class as a variable. However, using this : messes up for private modifiers. So if you still want to access something privately and differentiate, you're going to want to use attribute. Now let's just do cheese stuffed. And just to show that we can truly put anything in here, let's just print out made a new pizza. So now let's create a pizza. Let's give it a topping of sausage, bread of pretzel, and let's just keep it not cheese stuffed. And so there we go, made a new pizza. Now let's try printing out some of the attributes. We can print out cheese stuffed, which is false. We should not be able to print out topping. Correct. It says that topping does not exist because it cannot find it anywhere since it is private. This is the same for breading. If we just change it to breading, it has no idea what we're talking about. However, we can do things like make a new method that gives us the breading. Now, a method is essentially a function inside a class. It's like an attribute, but a function. We can create it using the method keyword, which can be shortened to mthd, which is more standardized. There's also md, but that can be a little not as straightforward as mthd. And method is a little long. However, I will just be using method for this. So let's create a method called describe. It's going to take in no arguments. It's going to return a string. So essentially what this is going to do is we're going to use what's this cool format string. It's just the backticks, then $, and brackets, and anything we put in there will be parsed into the string. Say, let's see. Let's create a variable called stuffed message. Let's set it to nothing. Then if we're cheese stuffed, let's set stuffed message to cheese stuffed. So we can just put stuffed message here, semicolon. So what it's going to do is it's going to say the stuffed message. So if it's cheese stuffed, it'll say cheese stuffed pizza with, we're going to put bread, and topping. So what it's going to do is it's going to return something pizza with the bread, and the topping. And let's just put a period. So now let's print out my pizza. Describe. Oh, shoot. It's called breading, not bread. There we go. Pizza with pretzel bread and sausage. Doesn't say cheese stuffed because it's not cheese stuffed. However, if we just change this to true, cheese stuffed pizza with pretzel bread and sausage. So that's our cool method. And we can also do stuff like take in parameters just to show that this is possible. So we can say like set cheese stuffed and we can take in a value called is, then set cheese stuffed to is, so we can have it as false. Print this out twice, and like my pizza set cheese stuffed, and we can just set it to true. You see, originally not cheese stuffed, now it is cheese stuffed. But what if we don't want to print describe every time we do this? What if we want it so it just automatically returns this when we turn it into a string? Well, what does it return right now when we turn it into a string? It just returns pizza. However, we can override this with bin methods. Bin methods can override built-in methods, which is why they're called bin methods. They're short for built-in. We can do this by simply postfixing a method with bin, and then the name. So in this case, we're going to do string, and we're just going to make it return describe. Now we can make describe private, and to do this, we can simply just put priv at the end of it, and unlike attributes, we can't put it beforehand. It must be after. So we can also put pub here. So now let's see what happens. Now we see when it's converted to a string, it automatically does that. It's automatically inherited by that. Now you can find a bunch of different functions that are all doing different things in the documentation, but I'm not going to be going over each and every one because there's a good chunk of them, and I frankly don't think a lot of them are really necessary. But now let's talk about what the best use cases are for classes. Classes are really useful if you need to repeat a bunch of data in functions and ways to modify the data. You can use a class and just simply encapsulate things. Things like objects in games or tables or other things can easily be captured using a class. However, there are plenty of scenarios in which you want to simplify down to a struct or an enum property, and you definitely want to be looking out for those. For example, if you want to encapsulate data but you don't have any functions on it, you're going to be using a struct, like the vector3. Didn't have any functions, but it used all the data. If you're going to be having multiple accepted in the same scenario, you're going to want to use an enum property. But those are the basic usage scenarios, and those are important to know, yet we're not yet done with classes. We've still got two more things to cover: static and inheritance. We'll cover static first. Static means that it can be accessed outside of an instance. What does that mean exactly? Let's create a new class. Let's call this myStatic. Now, what I'm going to do is I'm going to add a static with stc. You can also type out static, but stc is shorthand for it. Looks nice. So we can just say static myStatic. Oopsies, myStatic attribute. And let's just set it to 5. Now let's have another one. Let's say this is public static, and let's just have public. Just call this my attribute. Well, let's set it to 6. Now let's try something. Let's try printing out my static and then my static. Well, yeah, that too. And then we have my static and then my static attribute. Let's see what happens. It's crashed because it doesn't have a my attribute method yet. This is because we haven't instanced it. Since my attribute is not static, it has to be instanced first. If we do that, then we can access my attribute. However, with the my static, you can just access static from any context. This is the same for methods. We can create a method, static, my static method. I'm just going to print out, hey, whoopsie. And then we can have another one that's just my method. This one prints out, hey, yo. Oh my god. Alright, so let's try my method. Let's try out my static method. So both work right now. Oh, I probably shouldn't be printing these, the return values. But both of these work. Whoops. Both of these work. However, if we remove the instance from here, it crashes because it has to be instanced for it to work. Now let's talk inheritance. Inheritance is essentially you can have parent classes that give their attributes. If I just create a comment here, we have our parent class and it's got all of its attributes. You have child A, child B that inherit from the parent class. They have all of the attributes from the parent class and all of the methods unless they overwrite them. We can see this by creating a class parent. And let's give it a number attribute. And for the ingredients, let's just take in a number and set their number X to that number. Now let's create a child class, and we can make it inherit from the parent using the skinny arrow. So the child feeds into the parent. And I'm not going to declare X. However, I'm going to create a new constructor that sets X to Y. Now, normally this would throw a variable if we didn't have our parent already defining X for us. However, since the parent defines X, since the parent defines X, it automatically works. Now we can do like Y plus 5. It'll say 17. However, if we just dump parent here, it'll say 12. Now this works the same for methods. If we have a method called like print X, and just prints out X, then we don't have to do that there. So let's just print X. And if we just put child here, it prints out X. But you see, there isn't even an X defined or a method called print X. Yet it still works. That's the power of inheritance. Now this was the final this was the final subject to cover for our next project. Alright, so now we'll be doing our second project, which is going to be an object-oriented take on some sort of quiz program. So the way we're going to do this is that we're just going to have a quiz class and a question class. So yeah, let's start off with the question class. Let's define a new class with class question. Now the attributes we're going to have is we're going to have the actual question itself, which is going to be a string. We're going to have the choices, which is going to be a list. And we're going to have the correct answer, which is going to be the index of the correct choice. Now we're going to do A, B, C, D. So we're going to have 4 choices. And then the user will input A, B, C, or D, corresponding to which option they want to choose. We're going to make all of these private so that people can't access them outside of our interface methods. So let's create a private field called question. Let's make it a string. Create a private field called choices, and it'll be a list. And a private field called correct answer. It'll be a num, and that'll be the index. Now we're also going to want to define a field called letters, and it's going to be the list of A, B, C, and D. And this will be used for displaying our choices and getting them and figuring out which is which. But since this isn't going to be instance specific, we're going to make it static. And then letters, it's going to be a list. It's just going to be A, B, A, B, C, and then D. So now we're going to make our constructor. It's going to take in a question. It's going to take in our choices. It's going to take in a correct answer. So first, let's just set everything. Use attribute to set the question to the question. Choices to choices. Oops. And the correct answer to the correct answer. Now we're going to do these. We're just going to do a few things to force the entries to be in the correct format. We're going to assert that it gives us 4 choices using this assert keyword, which basically just allows us to say, if this is false, throw an error. And it's going to be really useful for future where we want to have specific constraints just like this. We can just use the assert keyword. Then we're also going to make sure that the correct answer is greater than or equal to 0, and it's less than or equal to 3. This is so that they can't give us like -1 and expect the correct answer to be entered as -1. So let's create an ask method. It's going to return a Boolean. That's going to be whether it was the correct answer or not. What we're going to do is first we're going to print out the question. So we're going to do print line question. Then we're going to do a for loop that goes from 0 to 4. So we're going to be doing 0, 1, 2, 3 for each question. So what we're going to do is we're going to print out the corresponding letter by just getting the nth letter. So that question 1 will have letter 1, question 2 will have letter 2, etc. Then we're just going to add some white space. And now we're going to use a do a while loop here. So we're going to have our answer variable. And then we're going to want to get the answer at least one time. So we're going to use our do a while loop. Got that. And now we're going to add our condition. And the condition is going to be while it's not one of our letter answers. While not letters.contains answer. So do receive an answer while the answer is not one of our given letters. Then all we are going to do is we're just going to return that the correct answer equals the letters, the index of our answer in letters. So if it's A, it's going to give us 0, which would be the first letter, which is so if we enter 0 for our correct answer, it'll be that. If we enter B, it'll give us 1, and so on. So now we can create a question like this and just say, let's give it the question, what is the capital of France? Then we can have a list that's like Paris, London, Berlin, Madrid. And then the answer is obviously A, so that's going to be 0. Then we can print out the response of Q1 ask. So let's see what this does. Let's see, into course, JPizza, OO quiz, and the run flag. Now to give us something wrong, false. It's not London. Let's give it the right answer. True. Let's give it a letter that it doesn't know. It just asks us again. Now let's make a quiz. First, I'm going to create a few more questions. So do Germany, England, Spain. So it should be what? 0, 2, 1, 3. Yeah, okay. So we have all these different questions, and we're going to use them in our quiz class. So the quiz class is going to be pretty simple. We're going to have a questions attribute. That's just going to be a list of the questions. It's going to be private. And then our constructor, we're going to use this spread operator, so we can just accept as many questions as we need to. And it doesn't have to be ordered in a list or anything. And we're just going to set that up. Pretty simple. So now let's create a method called askAll, and it's going to give us a number, which is going to be the amount we got correct. So we're going to set our score to 0. Okay, we're going to set our score to 0. We're going to go for each question in questions. If question ask, so if we ask a question and it's correct, we're going to print out correct and then add 1 to our score. Otherwise, oops, really messing up here. We're going to print out wrong. And then at the end, we can just return the score. Then we can have some other ones like question count, which gives us the amount of questions we have, or score, which will give us a percentage score. So just extra useful stuff like that. Now let's just create a new quiz. Just give it our questions. Like that, nice and simple. Don't have to wrap them in anything. And let's just say score equals quiz, and then we're going to do score. So let's just print out you got in percent. Do better unless you got a 100. Just merge those two lines. So let's see how this works out. No crashing so far, that's good. So let's just answer wrong for all of those except for that. Oh, there's a problem. Let's multiply this by 100. Let's try again. Yeah, so you see it tells us we got it wrong for all of those except for France, which is Paris. Let's just try going randomly. Got a 50%. That tracks. Now let's answer them all correctly. And we got a 100%. So that's a pretty simple way to write an object-oriented quiz. And with the system, it's pretty expandable. You just create a new question. It's like, what is... It's so easy. 2 plus 2. 1, 2, 3, 4. And then we just add that there. Oops. Let me just A, C, B, D. And then what is 2 plus 2? I think it's 3. I was wrong, but look at that. It graded it, and it perfectly incorporated it into everything. It's nice and simple, and easy to understand because of the object-oriented patterns. That's how you can make an object-oriented quiz. That's going to be our second project. And next, we'll dive into scopes. So let's cover scopes. Now, you've already been using scopes, but you might not just have noticed. A scope is essentially a container of all the variables. When you define an if statement, so if true, inside of here is a scope. If you create a variable in here, you will not be able to access it from outside. Now you can create a scope very easily just by using a pair of curly braces. And just like that it works. And so if we increment it so that show that there's a difference, see if we can print it there, but it's not working there. But you may be wondering, how do you create a dictionary since dictionaries are also defined as curly braces with the whole key value? It's actually pretty simple. If it's a statement like this, it'll be a scope. If you're assigning it to a variable like this, it'll be a scope. But if you're assigning it to a variable, you can wrap it in parentheses, just like that. And same with if it's a statement, and it'll become a dictionary. But also if you're doing some sort of function call, it'll be a dictionary. And anything where it's not a statement, it will end up being a dictionary. if you do still want to do something like that, like wrap it in parentheses, or have it as like the end of an operand, what you can do is you can use the scope keyword, which also allows you to give the scope a name. So you can do scope, and then in square brackets, you can do my scope. And then you can also return values from here too. So var y is 5, and then return y. Scope. Oh, yeah, that's true. That'll mess it up. However, it does work just fine if you assign it to a variable of some sort. So let's print out x, and you see it's 5. This is a pretty easy way to do some complex math and assign a single variable to it. You can just assign it to the end of a scope like that, and then return the value you want to inside without having to worry about all those variables and everything staying over just to assign that one variable. It's also very useful if you're doing pattern matching, which we'll cover next, since you can only have one statement, and other scenarios. You can also, if you want to get a little messy, do a function arrow return. So you function add one x. You can actually do the arrow and then a scope. Now, why you would do this instead of this, I don't know. Some people are crazy. Then you just return x plus 1. Print out add 1, 12. It'll work just fine. Well, no, it won't because of the system, but if you were to modify this code enough, it would work just fine. Should you be doing that? No. But, I mean, you can. It's also very useful whenever you just want to encapsulate some variables and keep them from being accessed from outside. Compared to creating an entire class for it or anything, we'll be using scopes in a good amount in actually the next section. So now let's talk about pattern matching. We covered this briefly when we were talking about sum and none with enum properties, but we're going to go more in depth on pattern matching. Now, if we bring back those enum properties, sum and num, so sum val and none, when we call sum 12, it's actually more of doing this, pub val ingredient, and then the type is just option. So it's really doing that just in this sort of enum sense. So if we do have some sort of class, it's called like data, we have some public attribute like x. Well, let's make a point class, which should be a struct. Actually, yeah, let's do that. Let's make a struct. Let's make a struct point. We got x and y. So let p1 is just some point 3, 4, 3, 5. Sure. Now let's pattern match something. Let's match p1 and do a point x, y, and let's print out just their sum. So that should print out 8. Look at that, it prints out 8, but it's not an enum. That's because it desugars any, it just destructs, not desugars, big difference. It destructs any class you give it if this condition matches. And the attributes have to be public too. So if this was a class and they were private, wouldn't work. Now, things you can do with pattern matching too, you can also compare things. Say only when this is 3, you want it to print out the y. When this is 4, when the y is 4, you want it to print out the x. Otherwise, we can use default and print out none matches. That works. Let's change this to 4. It's not working. Let's change this to 6. Change this to 4. I'm not sure what happened there. Haven't changed any code, but should be working when you guys run it now. It's all fixed, and look at that. It works. Since this is 4, it prints out the X. But if we change this to 5, none matches. Change this back to 3, prints out the Y, which is 5. Now pattern matching works, but what if we want to do more than one thing? Well, then we can use a scope, as teased earlier. And we can print out the Y and then like the Y plus 1. Oh, whoops. This is because it's currently detecting it as a, it's detecting it as a dictionary right now. But if we just change this to, so then we have the scope keyword, it works. Now it should be working without the scope keyword. I'm not sure what's happening there. So hopefully that will work by the time we get this published. But yeah, it's not that bad. It just says scope and then the curly braces. Right now it's parsing it as a dictionary. And then we have that. So that's how you can do multiple things. But what if you want to store this value? Well, we can actually assign the value of a match to a variable. Whatever's outputted by these is the value that's going to be returned. So if we just change these to that, for this we can just return y. So we have that, which is why we actually need a semicolon after match. Then we can print out y, and look at that. Well, I'll change this to +2 so we can differentiate between it. This one, it's 3, so it prints out y plus 2, and then we print out the value returned, which is y. So that works. Change this to 16, it's going to print out none matches. But if we change this to 4, it's going to print out 16. So that's how pattern matching works. It's very useful when you're working with things like optionals and enum properties. And it can also be useful in scenarios like this, when you need to do some quick comparisons and extractions. And also, assigning a variable too, because it can also be used just like a switch statement. Case 1 value, case 2 value, which makes it very easy if you need to return a value from a switch statement. So now we're going to be covering imports. Now I've got this file called hello.devp, and it's just got this function called sayHello in it. It'll print hello when called. So let's actually import this. Do this by doing import hello, and it'll just look for a hello compiled file or a hello.devp file. Then we can just do hello, say hello, and we can run this. Let me see, it says hello, just like we expected. We can also use a string, import hello. However, this will import whatever you give it here as the string. So if we have a folder like packages, oops, wrong one. Yes. And we do / packages. See, it says undefined variable because it wants us to use that, but we can't type that out. So you can use the as keyword and then put whatever you want after that. That's really useful if you want to import a library, but you want to use another alias. You can just use like anything you want here, and it will work. Something else you can do this with all class type objects, but it's mainly used for imports. You can use JavaScript style destructuring, where you put curly braces after the word var and then the arrow to whatever you're importing. And we can take things out, like put say hello in there, and then we don't have to use the namespace beforehand. Just like that. It's nice and easy. However, there is more if you want to go deeper with packages and imports, where you have a .jpizza folder in your user home. And you can also change where this is stored with the JPizza data directory environment variable, JPizza underscore data underscore dir, all caps. If we go in modules, we can drag our own modules in here. We can do things like create a new module. We're just going to call this mod. And then our main file has to have the same name as whatever we called it. So mod.devb. So let's just open this up and just paste this in here. Let's just delete this. Now you see that it's not even in here with us. However, if we do import mod, it works. We can import it from anywhere that we want to. And if we were to delete it, it doesn't work anymore. Now there are some other packages, such as built-in libraries. There's a ton of built-in libraries. There's not a lot currently, but there is a good chunk. There's a system library, sockets, HTTP server. You can all get them by importing them just the same as earlier. You can import IO file for file management, import time, import gens, just like that. You can even do import std, which is a built-in library written in JPizza, and we will be covering that later, more in depth of the features, but we will not be covering that just yet, because next we're going to cover headers, which work very well hand in hand with packages and imports. So now let's talk about headers. Headers are very simple. You do the hash symbol, A, B, C, a bunch of different identifiers and tokens, all separated just like that. And it'll modify the control flow of your code in a very special way. If you run this right now, it's going to get mad because this is an invalid header, especially now with the numbers. But let's look at a good example of what a header can do at the sort of minimum level. Let's create a Fibonacci function. It's going to take an n. So if n is less than or equal to 2, we're going to return 1. Otherwise, we're going to return fib of n minus 1 plus fib of n minus 2. Run this. Well, actually, we didn't call it. Let's get the 100th Fibonacci number. Now, this is going to be very slow because we're going to be getting a lot of duplicate numbers. A typical way to eliminate this is called memoization, where what you do is you store a dictionary object called a memo, and then every time a function is called, you store the function in their arguments and then the return value. So if you ever have a duplicate function call, like you will have many times here, it automatically just returns the value instead of calculating it. Well, instead of doing all of that boring work, you can just write memoize in a header, and it'll memoize the current scope. We can do it in the global scope, and that'll make all functions memoized. If we just do it in the fib scope, it works perfectly. And look at that, immediately returns. We can go up as high as we want. Well, I mean, we could, but it's going to get to infinity eventually. And pretty quickly, Fibonacci numbers grow pretty fast. Yeah, you see, it's ridiculously fast. Compared to earlier, we couldn't even get the 100th. Now we're at 1.2 thousandth. Another good example of a header is packages. This is what I was talking about earlier with packages going hand in hand. You can use the package header to designate where your code is coming from. If you do something like package my cool package, then what you can do is you can do export to package, and then only files that start with my cool package or yours starts with whatever their beginning of the package is, then only those can be imported from. So if we have our other package, my cool package other, then this also exports to the package only. You can have our say hello function from earlier. And you're not going to notice any issues at first. So let's import other say hello. See, it works. However, if we change this package to my cool awesome package, or just my awesome package, see, it doesn't work because we're not in the same package. This only allows package imports. However, if we change it to the very root, such as my, we can import it. This allows you to do things like create your own libraries in which they can only import functions from a specific file, because we can also do export to all to allow anything to import it. And then we can finally just do export to none, which doesn't allow anything to import it. You can also do specific things can be imported only, where let's say we have, say, like, let's just have a say function that prints out hello. We don't want people to be able to use the say function. It's just only going to be used inside. So what we can do is we can do export say hello. Then only the things that we mentioned in this export header can be imported. So we can do that. However, if we try to do like say and then make it say hello universe, can't do that. It doesn't let you use it. So those are headers and how they can interact with packages and be used for optimizing code. There's some other headers, such as making main functions in main classes that only run when they're not imported and will run automatically without you having to designate them as a specific run, which is really useful if you're going for some nice safe code that can be tested easily. And yeah. Now let's look at error handling. Sometimes you're going to want to catch an error and do things with it. Most languages have some sort of try-catch system where you have code that will throw the error inside of the try block. Then inside the catch block, you say like, my error name X. And then you do stuff with X, as X will be assigned the error if it catches that specific type of error. JPizza uses more Rust style error handling, or if you just have some error func and put square brackets at the end of it, it will now catch the error. So let's just have error func X, and it just asserts, remember assert from earlier, and make sure a condition is true, otherwise it throws an error, and assert X is equal to 1. So let's see what happens if we print out error func of 1. It's not going to crash, but all it does is it gives me these empty parentheses. This is actually the return value. Let's return something. Let's return X equals 1. Sure. We have these parentheses around the value. What does that mean? Well, it means that it's a result. The result is something that contains a value if the code ran correctly. Otherwise, it'll return a value that contains an error. Now you can do a good amount of there's a good amount of functions that you can use on results that are used to handle them. So the first thing you can do is you can use OK, and this will tell you if something crashes. So I'm just going to create a variable. I'm going to get user input, enter a number, and I'll just change this to like X is greater than 5, then return X. So what we're going to do is we're going to get a result, and it's just going to be error func of input. So we can check if it's true. This will return true if there is no error. Then we can use resolve, resolve, sorry, to get to the value stored inside. Otherwise, we can set the error to catch. And this will return us the actual error. And we can see what that looks like. If we do this, so let's enter 5. It gives us this list. It gives us the error type, and it gives us the error message. And if we actually just want to throw the error anyway, which seems a little useless, you can use the fail function. So yeah, it'll just throw the error anyway. However, if we enter a number greater than 5, it'll print out the value stored inside. So error handling is pretty simple. If you want to, if you really like the try-catch architecture, you can do some try function. You can make your own try function. That's just execute, and then make it a function. Oh, wait, this is right now. Now the type is function. Just don't type it, I guess. Execute and then catch. And what you can do is you can just do run the execute code, enter, it runs execute, get the value of that, then if res, if it's not okay, then just run catch of res.catch. I guess you should probably change this, except, and then something like that would work. But you can ultimately make anything with this sort of lower level and error handling. It's a lot simpler too. Just a pair of square brackets and all errors are returned as a result. It also forces you to use the error, even if it is true. And you may actually be wondering, what if you use the resolve even if it's not okay? Well, oopsies. Now there's nothing there. Just gonna pretend like that's good looking code. If we just enter 5, unresolved error in catcher, it just gets mad. So you should never use resolve unless you know it's okay. Yeah, that's how you can do error handling. And we're going to be continuing our little error journey by looking at custom errors in just a few seconds. 3, 2, 1, and now we're going to look at custom errors. Now we've already seen one example of custom errors, which is assert, in which we give it a condition, and if it is false, it gets mad at us. This is fine. This is not. And this is it's a more complex version of a custom error, but there's actually another custom error we can do where we can give it a custom message. You just throw code broke, and this throw keyword will take in our message and give us a thrown error and say code broke. However, you may want to add a custom type. So you can just say broken code. And so this will give us a broken code error with the message of code broke. You know all kind of stuff with this. So you can say broken code, make a function that just takes in a message, like string, and then you can just throw a broken code error with the message. And now you've made a custom error type. So you can do broken code of error was encountered. And just like that, you've automatically got your own custom error. It can be used in all kind of scenarios in which you want to make some sort of code that raises an error upon certain inputs that shouldn't be allowed. Or you're building a library and you need it to automatically raise an error if some request returns invalid or something. And so throw and assert can be really useful in these scenarios. Now we're going to be looking at something really cool, and this is references. Now, references may be a bit different than other languages because it's not referring to the memory address or pointers, as they would be called in other languages if you've ever worked with those. Instead, a reference is more like a wrapper around a value that can change the internally stored value. You can think of it as like if we have a struct called box with a value inside, than if we just had some function that allowed us to change it, and we just binded that to the arrow. It's kind of similar to a variable, and you kind of think of variables as normal references. It allows you to assign things and make stuff like mutable lists, which aren't normally possible. Let's look at that first example, actually. Let's create a list, and let's create just a list of numbers. In other languages, you would be able to do like the 0th item of the list is equal to 5, and then you can print it out. However, this is not a reference, so you can't set it. Things like attributes and list items are not actually mutable in JPizza. So what you have to do is use the ampersand to turn it into a reference. So basically what this is doing is this is taking the reference and then setting the value here to 5. You can see if we set a variable to a reference, when we do x is 5, this actually gives a different value. This is not setting the reference at x, because if we check the type of x in between, we get a reference number, which is wrapped in square brackets. A reference will always wrap the type in square brackets, and then just a normal number. However, if we wrap x in parentheses, so it gets the value at x first, and then uses this arrow operator on it, same type, different values. Now, you may notice some errors when you try to do something like 3 plus x, or it's one of the ways where there are some errors with certain types where it'll get mad. What you can do, though, is you can dereference the value at x. So we can do that. Like an example is with if you have a referenced list like this, and you try to add something to the list, it'll get mad because it gets a reference of a list and not the list itself. So instead, you dereference the list, and then it works. So you always just want to keep an eye out for that, because there are some built-in library classes that do automatically use references so they can be mutable, and you're going to want to make sure to remember to dereference them whenever you use them. So yeah, I hope you learn something about references, because we're going to be seeing them in the next one when we cover the standard library. So now let's look at the standard library. Now, similar to other standard libraries, this is just called an std in the source code. So we can do import std. And this contains a lot of useful classes for static typing and other related fields, and things like null optionals. So the most significant one you'll probably see is the tuple class. So we can destructure the import to get the tuple class out. Now we can use this to create a fixed pair of values, such as a coordinate point, and it allows us to create mixed types, but the type will actually show us the types of the values we give it. That might be a little confusing, so let's look at an example. Let's create a point. Let's just create a tuple of 2, 3. This can take in any amount of arguments. It does not care. So now let's print out the type of x. Oh, hold on. I made a typo here. Okay, so yeah, now it works. And as you see out here, it prints out each type it's given separated by a comma. So we can put a string in there, and it'll put a string in there. This is super useful when you don't want to be accepting parameters one at a time. Can't accept a list because can be a bunch of mixed types, and you don't want to check each type. But you can't accept an array, which is going to be a statically typed list we're going to get into in a second, because you want to have more than one type, or you want a fixed number of types. So the tuple is great for accepting stuff like a point, because we can have some function like distance, and we can just put in num here, num there, just like that. And now it has to give us the 2 points. And then, of course, we can use the nice distance formula. We're just going to be, oops, let's probably change this to like A and B. Tuples use references, so we're going to have to do that. A0 minus dereferenced B0 squared plus dereferenced A1 minus dereferenced B1 squared to the power of 0.5. And now we can just do distance, and then tuple 1, 0, 0, tuple 1, 1. And just like that, we have the square root of 2, which is true because a right triangle with a base and height of 2, of 1, is going to have a hypotenuse of 2 because Pythagorean formula, a squared plus c squared equals c squared. However, we also have other classes such as array. Array is like a list, but it only accepts one type. So let's create an array, so we can just give it a bunch of types, but since it takes in an arbitrary amount of arguments, we can give it as many as we want or as little as we want, we have to explicitly give it the generic type, like that. So let's look at the type of the array. Well, that is not a very useful type. It's being a little buggy right now, but luckily the bug was all in your head, and it works perfectly. So you see the type is an array of numbers, and it can only be numbers. We're going to test this out by adding something that is not a number, and it's going to get very mad at us. But let's do it anyway. So let's add hello. And then we're going to print it out. So the brand new item right there, and it's going to be beautiful. Let's look at it. Well, it didn't quite like that. So expected type num but got string. So since we put num here, it's not going to let us do that. However, if we just change this to like 23, oh hey, look, it's fine. And you might be wondering why there's quotes around that. That's just because it's going to be a string. You don't have to worry about that. They're numbers. Don't worry. But yeah. Then this has a bunch of functions. Like you can have, there's an add all function, 1, 2, 3, 4. And will also, all of these functions will enforce the types. So that'll add everything you give it. Then you've got all the normal list functions like join, contains, index of, size, string. And it'll just let you do it. So, except just in a nice object-oriented and statically typed form. And then, of course, as always, you can just use any, and then you can do all the chaos you want. What's nice about array is that it has references automatically. So we can automatically do something like that, and it just works. They automatically use references for everything, and it's great. It's the same for map, which is a statically typed map class, or dictionary, as they're better known. So what we can do is we give it a key value and a value type. So we're going to give a key type and a value type. Then we just give it a bunch of pairs, like A2, B3, C4, like that. And it'll just convert that into the map. I'm just going to put it back all in one line. You know, looks nicer. Kind of. It's probably fine. It's not important. And then we can give it a key and set the value like that. Look at that. It works. And then this is also type enforced. So if we do something like map set, and then we're going to set a to like the string 3. No, you can't do that. And there's other fun little parts of the class of the std library, like option, so like sum, none. Then there's the statically typed version of option, which is box and empty, and a bunch of other stuff like that, which is really nice. So it just offers some fun little alternatives and helpful classes and functions for your coding experiences. So that was my big old JPizza course. I hope you enjoyed, and I hope that you learned something new about the language, or found that you're going to be using this language for your project sometime in the future. I'd love to see what you build with it, and it's going to be constantly improved. So if you're not really feeling like you want to work with it right now, but want to come back to it later, always make sure to check in. We've got a bunch of different platforms that we're accessible on, and I think you'd really enjoy working with it.